This is Mr. Alexander, and I want to take a few minutes to show you how to solve equations that have radicals. This is what we did in class on January the 14th and January the 15th. So let's jump right in and start with an equation that looks like this. Square root 5x minus 20 equals the square root of 3x minus 10. Now, when you're solving, what you're trying to do is get the x by itself. And this is actually the easiest problem you're going to see. The first thing you ought to do is square both sides. Because squaring it and taking the square root, those are inverses of each other, and they simply cancel each other out, leaving us with 5x minus 20 equals 3x minus 10. So they cancel each other out, and all we have to do is solve for x. So I'm going to get the x's on the left-hand side by subtracting 3x from both sides, and then I'm going to get all the constants on the right-hand side by adding 20 to both sides. That's going to leave me with 2x equals 10. And then when you divide both sides, now the last step here is to divide both sides by 2, leaving us with x equals 5, which is the answer. But with these square roots, once you get a solution, you're going to always want to plug it back into the original equation to make sure that it makes sense, that you get a true answer. So I'm going to do that right here on the side. The square root of 5 times 5 minus 20. And we're going to see if that's equal to the square root of 3 times 5 minus 10. Okay, of course, 5 times 5 is 25 minus 20, that's the square root of 5. And 3 times 5 is 15 minus 10, well, that's the square root of 5. Those things are equal. That's a true statement, so this is the correct solution. These problems have varying degrees of difficulty. So the next kind of one I want to talk about is this one right here, the square root of 2x divided by 3, and then minus 1 equals 3. So the first thing you want to do is make sure that the square root is isolated, meaning there's not plus or minus anything on there. If you have multiply or divide on the outside of the square root, it's not a big deal, but generally speaking, you want to get the square root by itself. So you want to start by adding 1 to both sides, which give us square root of 2x divided by 3 equals, when you add 1, that's 4. So we want to square the entirety of both sides, leaving us with 2x divided by 3 equals, well, 4 squared is 16. Okay, and now we're still trying to get the x by itself, so we want to multiply both sides by 3, because the opposite of divide by 3 is multiply by 3. And that's going to give us 2x equals 16 times 3. Okay, 16 times 2 is 32 times plus another 16, that's 48. And then divide both sides by 2 to get x equals 24. Now before I can be sure that's the right answer, I need to plug it back into the original equation, make sure I get an answer that makes sense. So I want to do the square root of 2 times 24 divide by 3 minus 1. See, 2 times 24 is 48. 48 divided by 3 is 16. So it's going to be the square root of 16 minus 1, which equals 4 minus 1, which equals 3. That 3 is the same as that 3, so I got an answer that makes sense. The correct answer is x equals 24. Now here's a bit of a tricky one, because we've got variables on both sides. Now generally what you do is you try to get all the variables on the same side, but it's hard to do with the square root and the problem there. So we'll start by squaring the entirety of both sides to get rid of the square root. So it gives me y squared equals 7y minus 10. Now that squared term is the highest exponent in this problem, which means this is a quadratic, and we're going to solve this thing the same way we would solve any quadratic, by getting a 0 on one of the sides. Now I want that y squared to stay positive, so I'm going to subtract 7y and add 10 to both sides. It's going to give me y squared minus 7y plus 10 equals 0. Now you have a variety of tools. So you have a variety of tools in your toolbox to solve quadratics. You can use the quadratic formula, you can use factoring, whatever tool you like to use. But this one's easily factorable. So we're looking for two numbers that multiply to 10 but also add to negative 7. And that is just negative 5 and negative 2. So this is just y minus 5 times y minus 2 equals 0. Now if you set these both equal to 0, you can solve for y. So we can say y minus 5 equals 0 and y minus 2 equals 0. And then all you need to do is simply solve for y by adding 5 and adding 2. Y equals 5 and positive 2. But usually when we've got a quadratic, not usually, but sometimes when you have a quadratic, it pushes out an extraneous solution. So this is where it's very important to go back to the original equation, y equals root 7y minus 10, and plug in the values we've got. So we'll start with the 5. 7 times 5 is 35, minus 10 is 25. So the square root of 25 is 5. And so 5 equals 5. This is good. That one's fine. Let's check this one. So y is 2. Square root of 7 times 2 minus 10. Alright, 7 times 2, that's 14. Minus 10 is just 4. Okay, great. So 2, and this is the square root of 2, that's equal. That checks out. This one's a check too. So this one has two solutions, 5 and 2. There's no extraneous solutions in this one. The last one I want to show you very quickly is this one right here. 3 root x equals root 5x plus 80. And the process is the same here. I said before we need to isolate the square root. In general, that's true, but in this case, we're not going to isolate the square root because it could divide by 3 and it'll just be divided by 3 over here. There's no way to isolate the square root without causing something going on over here. So we're just going to start by squaring both sides, the entirety of both sides. So 3 squared is 9. Square root of x is x. Notice that I squared both terms in there because that's how exponents rules work. Through multiplication, you square everything inside the parentheses. So that's 9x equals 5x plus 80 because that square cancels out with the square root. Now it's a pretty simple looking problem. Subtract 5x minus 5x. You get 4x equals 80. And then divide by 4 to get x equals 20. And before we can say that's the right answer, let's plug it back in. Let's see, 3 times root 20, does that equal the square root of 5 times 20 plus 80? All right, so 3 root 20. 5 times 20 is 100 plus 80 is the square root of 180. So are these two things equal? The 3 root 20 and the root, well, we could simplify this, but I'm just going to simplify this one. I happen to know that I can take a 9 out of that. That's just 9 times 20. Now the square root of 9 is 3, so yeah, these two things are equal. The solution checks out. That's the solution. So that's how you're going to solve equations with radicals. Generally speaking, just isolate the square root, square both sides, and that'll get you where you need to go. Thanks for watching.